Okay, so today we're going to be learning about complex numbers. So we're going to be talking about adding and subtracting complex numbers, multiplying, dividing them, and just simplifying powers of I, which is imaginary numbers. So let's get to it. So complex numbers. So what does that mean? So complex numbers is written in this form: A plus B I. Okay? A is the real number. Let's just write this real number. Bi is the imaginary number, which is essentially does not exist in the real world. Imaginary number. Okay? So let's do one example. Okay. Let's express the square root of -9. So let's simplify this because this can be seen as where do we start? So let's break this apart. So it has a negative and a 9. So it's -1 times -9. Okay? So now we're going to take the square root of 9, which is 3, right? So -1 actually equals I. So we're going to simplify this again, and we get 3I. Okay? Let's do another one. So example number 2. The square root of -24. Okay? We're going to break this apart again. Square root of -1 times the square root of 24. Okay, so now let's break down the square root of 24. So 20, let's see, 6 times 4, we can take the square root of 4. So we're going to do square root of 6 times the square root of 4, right? We're going to simplify this, which we get square root of 4 is 2. We can't take the square root of 6. I mean, we can, but it's a rational number, so we're not going to worry about that. We're going to keep it as square root of 6. And -1, square root of -1 that we figured out is I. So let's simplify this. 2I to the square root of 6. And that's it. Try this one by yourselves. What is it? It's square root of -84. Same process as -9 and -24. Try it. So we're going to break this apart again. Times square root of 84. So what two multiples gets 84? Let's see. 84 divided by 2. 84 divided by 4. 84 divided by 4 is 21. Okay. Times the square root of 21. Why? Because 21, because these two multiplied together gets you square root of 84. So now let's take the square root of -1, which is I, square root of 4, which is 2, and the square root of 21, which we can't. Can we take the square root of 7? 3? No. So it's just the square root of 21. And that's it. Okay. So now let's say you're asked to plot a complex number on a complex plane. So what does that mean? So let's write this out. Plotting complex numbers, right? Because complex numbers has a imaginary part, we have to graph it on a complex plane, which is, I guess, quote unquote, specializes on imaginary numbers. So let's write this note. So we know that horizontal, which is normally the x-axis, will be the real part, which is a. And the y-axis will be the imaginary part, which is bi. Recall that a plus bi is how we set up our imaginary numbers. Okay, so let's try to graph one. -2 plus 3i. It's very simple. You can just draw a random graph. Okay, -2, 1, 2. Now we're going to go to imaginary part. Real part, 2. Now imaginary part, 1, 2, 3. That's it. Let's try one more just to make sure we're understanding. So 2 minus 4i. Let's draw the graph again. Let's go in 2 to the right, 1, 1, 2, and 4 to the bottom. 1, 2, 3, 4. So it's the same way as a non-complex number. Okay, so now we're going to be doing adding and subtracting complex numbers. So to add or subtract complex numbers, we combine the real parts and then combine the imaginary parts. So let's do an example. So adding and subtracting complex numbers, right? Example number 1. 3 minus 4i plus 2 plus 5i. Okay, so we're going to add 3 plus 2. So we're going to add 3 plus 2, which is 5. 5, okay. And -4i plus 5i, which is I. So why can't we add 3? Why can't we subtract 3 minus 4i? Because it's from different families. Think of this as 3 minus 4x plus 2 plus 5x. Can we add 5x plus 2? No, because it has different families, which is x is associated with that number. So these two match and these two match. So let's try another one, which is example number 2. -5 plus 7i minus -4 plus 2i. Okay, so be careful. On the subtracting part, you have to distribute the negative. Okay, so we're going to distribute the negative. Let's simplify this again. -5 plus 7i plus 4 minus 2i. So now let's reduce this, which is -5 plus 4 is 1, and 7i minus 2i is plus 5i. Okay? Let's do one more that distributes the negative. Just make sure we are distributing negative, not we're going to get the wrong answer. 2 plus 5i minus 3 plus 4i. Okay. We get 2 minus 3, right? 2 minus 3 is -1. Now 5i minus 4i is, what is it? Plus 1i. Yeah. Okay. So now let's get to multiplying complex numbers. So multiplying complex numbers. Okay. Let's do example number 1. 4 times 2 plus 5i. So what do you think we're going to do? We're going to distribute the 4 to the 2, and to the 5, which we get 4 times 2, 8, plus 20i. That's it. Just think of I as x if the I is really confusing you. So let's try another one. So we get 1/2 times 5 minus 2i. So we're multiplying times a fraction. So what do you do? Same thing, distribute. We get 5 divided by 2 minus 2i divided by 2, which just simplifies as 5 divided by 2 minus I. And that's it. Simple as it gets. So this is okay. Okay, so for dividing, we have to find the conjugate, so for dividing, we have to find the complex conjugates for each number. It doesn't make sense right now, but let's let's understand what's a complex conjugate. Okay. So example number 1. 2 plus I 5. Square root of 5. So what's the conjugate of this number? The conjugate is basically the opposite. So we're going to change the sign, which makes this 2 minus I to the square root of 5. So let's do another complex conjugate. So let's do example number 2. -1 divided by 2i. So what's the conjugate? The conjugate would be, just remember flipping the sign, which is 0, because there's no number here, 0 plus 1/2 I, which is just 1/2 I. Okay, so we're gonna need this information for dividing. So now let's do a little bit more multiplying. Okay, so two complex numbers. Wait, no. Okay, given two complex numbers, meaning example numbers like, here, let's write another example. Here, let me bring this down. Okay. So example number 3. 4 plus 3i times 2 minus 5i. So whenever we're multiplying two complex number, first we use the distributive property, or which is aka FOIL method. And now we have to remember that t squared, that I squared equals -1. So why does it equal -1? Just extra information. I times I is the same as square root of -1 times the square root of -1, which is just -1. That's it. That's why. Okay, so let's try this. We're going to FOIL, right? So we're going to do 4 times 2, 8. 4 times -5i, which is 20i. Okay. Now we're going to do 3i times 2, which is 6i. And we're going to do 3i times -5i, which is -15i squared. Okay, so let's reduce this. Here, let's actually draw an arrow. So 8 minus 20i plus 6i, which is 14i, I believe. And let's simplify this one right here. Remember, I squared is -1. Here, let's write this right here. So I squared. So now let's simplify this again. So we get what? 8 minus 14i minus 15. What's... Oh, whoa. See, I messed up here. -1 times -15 is +15. So 15 plus 8 is 23. Remember this right here. Minus 14i. And that's it. So we're just going to use the FOIL method the same way. So let's just try one more. Just remember, like I said before, just think of this as x. Because I know y'all have done a lot of factoring. Let's do example number 4. Okay. 3 minus 4i times 2 plus 3i. Okay. So we're gonna FOIL 3 times 2, 6, right? 3 times 3i, 9i. -4i times 2, -8i. -4i times 3, -12i squared. Okay. We're gonna reduce this. Let me use arrows. I don't know why I keep doing that. Okay. 6. 9i minus 8i is plus I minus 12i squared is -1. A little reminder, which now we get 6 plus I plus 12, right? -12 times -1 is +12. Now we get 6, 7, 8, 18 plus I. Alright, cool. So that's it for multiplying complex numbers. So now let's do dividing imaginary numbers. This gets a little more complicated, but it's super easy. So first, we're going to write down the division problem as a fraction, right? Determine the complex conjugate of the denominator. Then multiply the numerator and the denominator of the fraction by the complex conjugate of the denominator. Then we're just going to simplify. So, sounds confusing, but let's do example number 1 from dividing conjugates. Complex numbers. Okay. So example number 1. This right here. Okay. 2 plus 5i divided by 4 minus I. So we're going to find the conjugate of the denominator, right? If you don't know, the numerator is the top and the denominator is the bottom. It's a FYI. Okay? So we're going to multiply by its conjugate, which is 4 plus I. Whatever we do in the bottom, we have to do it on the top. So now what do you think we're going to do? So now we're going to multiply. Let's do the parentheses because it makes it readable. So 2 times 4, 8. 2 times I plus 2i. 5i times 4, which is 20i. Then 5i times I is I squared. Okay? So now let's do the bottom. 4i. Okay. 4 times 4. 16. 4 times I is plus 4i. Negative I times 4 is negative 4i. And negative I times I, negative I squared. Yes. Okay, so now let's simplify this. So let's do this one first. So 20i plus 2i is 22i. Let's write this out a little bit here. 22i, okay, plus 8. Now we're going to do plus 5, negative 1, which makes this 22i plus 8 minus 5, which we get 5, 6, 7, 8, 3 plus 22i. Okay, so now let's do the bottom one. Okay, let's reduce this. 16 plus 4i. 4i minus 4i is what? 0. Minus here. Minus I. Oh my gosh. Minus negative 1. Right? We get 16 plus 1, which is just 17. So now we're going to simplify this into its most simplified form, which is just 3 divided by 17 plus 20i into 17. Why do we want it like this? Because we want this in its a plus bi form. Here, it's not in its bi form. So we have to do it this way. Okay? Okay, and last part. So we're gonna be doing the powers of I. So I recommend just memorizing the first 4. So powers of I. Okay. So I to the first power is I. I to the second power is negative 1. I to the third power is negative I. And I to the fourth power is 1. That's it. So I'm just going to explain why. Obviously, this one, just I times to the power of I is just I. And for this one, we already did the work, but let's do it again. Negative 1 times negative 1 is negative 1. For this one, we're going to reduce this as 2 times I, right? Because I to the power 2 times I to the power 1 is I cubic, which gets us negative 1 times I, which is just negative I. So now let's reduce this one as I to the power 3 times I, which we get negative I times I, which we get 4I negative I times I, oh yeah, which we get negative I squared, which we get negative I squared, which reduces as negative times negative 1 is 1. So memorize this as, it firstly goes as I, negative I, negative 1. Oh, my bad. So just memorize this. So just memorize this as I, negative 1, negative I, and 1. So let's do a problem where we have to simplify. Let's see, problem number 1. Let's do one of these. I to the power 35. Okay. So I always start from the fourth power. How many times can 4 go into 35? So 4 times 8 is 32, right? So we're going to write this as 8, 4. So 8 times 4 equals 32. So we need 3 more to equal 5. So we're going to multiply this by I to the power 3, which we get 1 times negative I, which gets us negative I. Okay, let's do one more. 18. So how many times can 4 go into 18? You can go 4 times, right? So 16. So 8, 4. We need 2 more to equal 18, which gets us 1 times negative 1, which is negative 1. That's it. And that's it for complex numbers.